Hi guys, so this is for Module 4.2, Transversals and Parallel Lines. Our essential question is how can you prove and use theorems about angles formed by transversals, so that's a new word, that will intersect parallel lines? The shortest answer I can give you is, well, first we have to establish a postulate regarding pairs of angles. All right, so a new one that we're going to learn about and we'll talk about is called the same side interior angles. Okay, and there's some more there. That's why I put the etc. Now the postulates, they allow you to prove a theorem or a problem. Okay, so you have to focus on the postulate. All right, the postulates, the ideas. Then you use them to solve. All right, so identify the postulate. You just figured out how to solve the problem. So first definition is a transversal. All right, what is a transversal? A transversal is a line that intersects two coplanar lines. So basically, here's two lines. Okay, we'll call this line L, and then a second line, and we'll call it line M. A transversal just intersects both of them. Okay, they usually denote it with a little t. Okay, and it intersects two different spots. Okay, that's a transversal. All right, the postulates to know, big time. So these are the postulates, the ideas that you need to have off the top of your head, be able to recognize off the top of your head, um, just to be able to solve certain problems or even proofs. All right, so the first one, I'm going to use red because there's so many, I want to make sure I color code this. Corresponding angles. Now, corresponding angles lie on the same side of a transversal and on the same sides of the intersecting lines. So, let me close the window there. All right, so corresponding angles would be angle 1 and angle 5. That'll be here and here. Okay, so notice how they're basically, think of them like two radar dishes aiming at the same direction. Okay, they're both aiming over at the same satellite. Okay, all right, so same side interior angles. Let's use a different color. Let's use ooh, green. So same side interior angles lie on the same side, okay, of the transversal and between the intersecting lines. For example, angle 3 and 6. Think of it like two brothers. They share the same bedroom, right? So they're basically in the same room, but just one different corner. Okay, so that'll be same side interior angles. Okay. All right, alternate interior angles. So let's use blue. Alternate interior angles, that's a big one by the way for geometry. Okay, alternate interior angles are non-adjacent angles that lie on opposite sides of a transversal between the intersecting lines. For example, angle 3 and 5. So angle 3 and angle 5. Now, fun fact, there's actually a theorem about alternate interior angles. Basically, the definition of the theorem basically just says if two parallel lines are cut by the transversal, which in this case it is, then the pairs of alternate interior angles have the same measure. Basically, they're saying, well, angle 3, whatever its measurement is, it's going to be the same, or in a situation like this, congruent to angle 5. All right, so if angle 3 was 30 degrees, angle 5 is definitely 30 degrees as well. That's because of alternate interior angle. If you ever see me write AIA theorem like this, I'm referring to alternate interior angle theorem. Okay, that's always good to know. All right, last up, alternate exterior angles. Now those lie on the opposite sides of the transversal and outside the intersecting lines. For example, angle 1 and angle 7. Okay, now basically those guys are going to be alternate exterior. So yes, they alternate, but they're both on the exterior. They're both on the outside, okay, of this whole uh, image here. All right. All right. Also, please note corresponding angles also have their own theorem. So basically, if two parallel lines are cut by a transversal, then the pairs of these corresponding angles have the same measure. So we were talking about angle 1 and 5. Well, basically, they're just saying, well, angle 1, okay, is going to be congruent to angle 5. So if angle 1 was I don't know, 120 degrees. Angle 5 would also be 120 degrees. So those are the big takeaways. Definitely memorize them, and we're going to practice them some more. All right, so we're going to prove alternate interior angles theorem. So basically, they go ahead and tell us, well, P is parallel to Q. Good. And then we have to prove that angle 3 is going to be equal to angle 5. Basically, they have to be congruent somehow. So we're going to prove it. Well, first things first. Number one, they told us this. They gave us this information. Okay, so P is parallel to Q. They gave that to us. Now, for step 2, they say angle 3 and angle 6 are supplementary. So let's look. Angle 3 and angle 6. Well, aren't those same side? Yeah, those are same side interior angles. So we're going to use the same side interior angles. There we go. And that's the postulate. Sorry for right now, the box. All right. And then all of a sudden, step 3 comes around. They say, well, angle 3 plus angle 6 has to equal 180. And that is actually very true. And that is the definition of supplementary angles. So definition of sup angles. Okay, I totally understand if you wrote that. If your teacher wants to write the whole thing out, that's fine. That's respectable. I'm just running out of time. All right, so angle 5 and 6 are linear pairs. So let's look. Angle 5 is right here. Angle 6 is right here. Well, they gave that to us. That's in the picture. That's just like, look at the picture, right? So that was given. They can always give you information just by a picture also. So remember, linear pairs are basically just like hanging out, sharing the same line. Okay, so that was given. All right, angle 5 and 6 are supplementary. And again, it looks like we're using the definition of supplementary angles. That's good to know. And then they say angle 5 and 6 equal 180. And again, that is actually, oh, wait, silly me. This is the definition of supplementary angles. My bad. Fill in the blanks, man. Really do get me every time. All right, so yes, angle 5 and 6 are linear pairs. And yes, 5 and 6 are supplementary. Now, it's not because the definition, it's because, well, the linear pair theorem. Linear pairs share a line, okay? So they have to add up. They have to be supplementary. Okay, so linear pair theorem. Apologies. I'm only human. All right. And then finally, angle 5 and 6 equal 180. And again, that's the definition of supplementary angles. Nice. All right, looks like we go ahead and do some substitution here, right? So they're saying, well, angle 3 and 6 equals 180. Well, doesn't 5 and 6 equal 180? So they equal each other, right? So it looks like we used the substitution property of equality. Good to know. And basically, if you notice, angle 6, if you subtract angle 6 here, just like in algebra, you did what you did to one side, you did to the other, they would cancel out, and all you're left with is angle 3 equaling angle 5. And that was also because the subtraction property, all right? Good old algebra 1 kicks in. So this is a subtraction property. Oops. Thank you, pen, for doing whatever you just did there. There we go. So subtraction property of equality, okay? Or you could also do minus symbol prop. I would understand what that means. All right, so that's the proof for alternate interior angles. All right, corresponding angles. So one more proof, basically same situation. If P is parallel to Q, okay, we have to prove that angle 4 and angle 8 are equal to each other, okay? So let's see, we're given the statement that they're parallel. They say that 4 and 6, okay, and 6 is right here, form a pair of what? And that is alternate interior angles, okay? So by using alternate interior angle theorem, what can we say? Well, we can say that angle 4 is congruent or equals to angle 6. And then we can say, well, 6 and 8, well, aren't those just vertical angles, right? So using the vertical angle theorem, we know that angle 6 is going to be equal or even better congruent to angle 8. So using the transversal, or I'm sorry, the transitive property, um, in angle 4 equaling angle 6, we just substitute in the measurement for angle 8 and for angle 6. Okay, so the result is instead of the measurement for angle 4 equaling measurement of 6, well, we substituted. So angle 4 equals the measurement of angle 8. Done. Okay, so it's basically like, um, angle 4, oh, u equal 8. Well, or I'm sorry, angle 4, u equals 6. And then angle 6 is like, yeah, I equal 8. And then all of a sudden, 4 just goes, hey, you equal 6? And then 8's like, yeah, I equal 6. What about you? Yeah, same thing. And then they realize, well, then by that logic, angle 4 equals angle 8. All right, that's the idea. But notice how we had to use alternate interior angles, we had to use vertical angles, so we had to know the postulates or the ideas to solve this or to prove it. All right, so now finding values and angles. So we do use this all the time to make sure roads in this situation are correctly angled. Otherwise, a road goes through a building, and that's not good, unless they're demolishing it. But, they usually plan that ahead now. Okay, so first things first, we have to solve for x. All right, so let's do that. What do we know about these two angles? This angle here, 2x minus 22, and this angle right here. Well, let's see. Vertical angles, right, would be the same. And wouldn't this angle right here be congruent to this angle right here? So by the transitive property, this angle right here should also be congruent to this angle here. These are actually alternate exterior angles. Okay, that's the postulate, the theorem that we're using. Okay, so basically, we'll call this angle. Okay, we're talking about this angle right here and this angle right here are the same. So you would say angle PRQ should be congruent to angle VTU or UTV. It's up to you. Now let's go ahead and substitute. So we're going to have 2x minus 22 equaling x plus 40. Again, I kind of switched them real quick. Sorry, I used the symmetric property real quick. And I'm going to go ahead and use subtraction property, the addition property, so that I can isolate my variable, which in this case is going to be x. 2x minus x is 1x, and 40 plus 22 is 66. All right, so notice how I use the postulate first, and then I worked down with my algebra and got my answer. All right, so you have to know what your angles are, okay? All right, your turn. So go ahead and find me the value for x. Solve for x. Okay, but also mention what postulate. So yeah, solve for x, okay? But identify the angle postulate you need to use. And that's first. Okay, then solve. All right, guys, have a great day. And if you have any questions, let me know.